Hello, everybody. So today we will continue our discussion in Chapter 5, Section 2. And what I'm going to show you is what the graphs of logarithmic functions look like. So if you recall in previous videos, you may have remembered me mentioning that logarithmic functions and logarithms themselves are the inverse operation of exponentials. So if you think back to what happens when you graph a function with its inverse, you hopefully will recall that a function and its inverse are reflections of each other about the line y equals x. So as an example, if I took the function y equals x squared, I do need to restrict the domain so it's 1 to 1, so it has an inverse. And then I took the function y equals the square root of x. If I graphed both of these functions, here is y equals x squared, just the right-hand side of a parabola. And then in blue, here is the square root of x. You would see that both of these functions are reflections of one another about the line y equals x. They have symmetry. The same thing is going to happen whenever we graph logarithmic functions with their inverse, which would be a parent exponential function. So it says, in the same coordinate plane, sketch the graph of each function. And the first one is f of x equals 2 to the x. And then the second one is g of x equals log base 2 of x. So also recall something about a function and its inverse. If you have an xy point right here, that same point will be up here, but it will be flip-flopped around. So this point xy becomes this point yx there. So keep that in mind, that the ordered pairs are going to flip. So if I take this function right here, f of x equals 2 to the x, and I substitute y in for that, I get y equals 2 to the x. Now to graph that, I'm just going to simply make a table. -2, -1, 0, 1, and 2. Now substituting each of those x values in for the x right here, I will get the following y values. 1/4, 1/2, 1, 2, and 4. Now if I were to graph that, draw my coordinate plane, and I draw some hash marks. I go to -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4. Here is the graph of that exponential. All right. Now, I want to graph this second one right here. Now, in order to graph that, you can see the first thing that I did is I removed the g of x and made it a y value. But I still don't know how to come up with values for in a table because it's in logarithmic form. But what you can do is you can convert it from logarithmic form into its exponential form. So we take this 2 and we take it to the y power, so 2 to the y, and we set it equal to x. So 2 to the y equals x. And that's what I get right here. So 2 to the y equals x. Now, what makes this different is when I make a table, actually I'm going to use a different color here. I'm going to use blue. This time, the inputs are not the x's, they're the y's. So what numbers am I going to put in there? Well, I'm actually going to put the y's in, -2, -1, 0, 1, 2. And when I put those y's in, I get the x's, 1/4, 1/2, 1, 2, and 4. So here I would input these y values, each one in for the y value right there, and then get an x value, which I then write over here. Okay. Now, by doing that, what you see is I come up with another table. But what I want you to notice is how those two tables are related. The x's and the y's are flip-flopped. They switch places because these two functions, this right here and this right here, are inverses of one another. They undo each other. So when I go to graph those, let me graph that second table. I'm going to graph it on the same coordinate plane. I'm going to 1/4, -2. Then I'm going to 1/2, -1. And then 1, 0, 2, 1, and 4, 2, like that. I get a graph that looks like this. And you can see if I drew a diagonal dashed line, they're reflections. So that's exactly what a graph of a logarithmic function looks like. It's in blue, and it's a reflection of an exponential. So here's a little bit of a summary. Of logarithmic functions. The functions are continuous. They have a domain. You can see that they do not cross the y-axis. So they kind of start at the y-axis and go to the right. So that means their domain is 0 to infinity, but not including 0. The range, this function does go down forever and it will increase forever. So the range is -infinity to infinity. There is an x-intercept. Now, if you recall, when we have an exponential function, it goes like this and it crosses at that point 0, 1. Well, remember, logarithmic functions are reflections of those. So when you flip that point 0, 1 around, you now have the point 1, 0. So that point 1, 0 is where the logarithmic function will cross the x-axis. This graph is increasing, and it is 1-to-1, therefore it has an inverse. Remember, we have the horizontal line test to test whether a function is 1-to-1, and this passes the horizontal line test. So there's some more notes about the graph of a logarithmic function. As I said before, it is continuous. It's a reflection about the line y equals x of an exponential function. Okay, so that's what I have for you today. As always, if you have any questions, feel free to email me. Have a great day.